Okay, so today we are going to go over finding the minimum length required for a vertical curve if the design speed is 70 miles per hour, the initial grade of the curve is -4%, and the end grade of the curve is 2%. So it's going to look something very similar to this. Excuse my drawing, definitely not an artist. But it's going to be a sag curve. And then they've also specified that the reaction speed of the driver is 1.2. So how do we find the reaction speed, or how do we find the length? So these two equations involve length and help us find length. So we have and these are just for sag curves. There are another two for a crest curve. But for this, we don't need the crest curve ones. All we need is these two. So for our sag curve, we can either assume that SSD is going to be less than L, or SSD is going to be greater than L. For this problem, I am assuming less than L for the first attempt, for the first trial. But I still have two unknown variables in this. I have L and I have SSD. So without the SSD, I'm going to struggle to find L. But I do have everything I need here to find SSD. So I come down, and this is our SSD equation, and then I have plugged it in, 1.47. That's going to account for our velocity being in miles per hour, so we don't have to convert. So our velocity of 70 miles per hour, and then T, our reaction time, is 1.2. Then we add that to our velocity again squared over 30, which is another converting factor for things being in miles per hour. Then we put in our deceleration, which for this problem I have assumed to be 11.5. Some people assume 11.3. Once again, it's a assumption, so there are going to be certain discrepancies. Over 32.2, which is gravity, minus 0.04. I did 0.04 for the grade because I always like to assume worst case scenario, which if you're coming in this way and you try and stop while you're on that -4 grade, you are going to have a much harder time stopping than if you're going up this 2% grade. So I always assume the worst case, which in this case is that 4%, and make sure to convert it to decimal. We're given it in percentage, so we need it in decimal for this equation, which the SSD comes out to be 582.53. So we can take that, we plug it into our SSD is less than L equation, which is right here, where A is G2 minus G1. So that is our 2% subtracted by our -4%. And once again, they're still in decimals. And then we multiply that by our SSD squared. Then it's all over 400 plus 3.5 times our SSD. And our length now comes out to 834.84 feet. So we plug that back into this logical statement right here, that SSD is less than L. So our L of 834.84 and our SSD of 582.53. And this logical statement does come out to be true. So we can now assume that the minimum required length for the specified vertical sag curve is 834.84. If this were untrue, or that was a false logical statement, we would come back up, we would plug our SSD into here, and we would test this logical statement to see if this is true. And if this were true, then we would plug that would give us our minimum length. But we found that this one was true, so our minimum length is 834.84. So with that minimum length down here, we will round it to the nearest hundredth. So since it was below 850, I rounded it down to 800. And we will find the elevation equation associated with this curve. And then using that, we will find the high or low point of the curve. So we know our length is 800. Our grades aren't going to change. And since it's a sag curve, we know later on we are going to be finding a low point. The only assumption I have made for this part of the problem is I have stated that the elevation of PVC, this station right here, the start of the curve, I said it was 0 feet because there's no specification in the question where what elevation PVC is. So I assume 0, it keeps the math easy. So to find our elevation equation is rather simple. It's given to us. We just have to plug in a few variables. So this is our baseline elevation equation, which can be expanded to this right here. And when we plug in our values, we have our G2 minus our G1 over 2 times our length, which is 800 since we rounded down, x squared, plus our G1, which is the negative 0.04, x plus 0. So our 0 is 0 because of this. That is our elevation at that initial station. So since we said it was 0, it's 0, and it doesn't really play too much of a role in this problem. Our x is the distance from PVC on this line. So our maximum x would be 0, or would be 800. And that would tell us what our elevation at this end station would be. So using that, we can solve that all out. We find that our elevation equation equals 0.0000375 x squared minus 0.04x. So that is the first part of this question solved. And now, how do we find the low point since it's a sag curve? So the low point, we take the derivative of this equation here, or of this equation here, and that will give us our distance along that line at the low point. So we take this, we plug in our numbers, so 2, our A that we found up here, and then our G1, once again, derivative, so it becomes 0.0000002 times 0.0000375x minus 0.04. Then we'll set it to 0, and we will solve for x. So our x, it's not really that legible. Oh, it's in the side. So our x comes out to be equal to 533.3 feet, or 33 feet. So we take this x, we plug it back into our elevation equation, which I have done here. So 0.0000375 times 533.33 squared minus 0.04 times 533.33, and we find that our low point of this curve is elevation equals negative 10.67 feet. So if we come 533.33 feet in this direction along that curve and measured how far that curve went down, we would find it to be negative 10.67 feet. So this is the lowest point that curve gets. I hope that has helped, and you guys have a good day.